Alright, welcome to class. Go ahead and get your composition book out. Make sure you're on a blank page. You're going to be taking quite a bit of notes today. No moaning and groaning. It's just time to get started. Alright, what you see in front of you is a question. Let's read this. A bicycle shop designs a new gear system for their bikes. They use a 4-inch gear for the bikes with a 22-inch wheel diameter. If the ratio of the gear to wheel diameter remains constant, what is the size of the gear for a bike with a 26-inch wheel? Right, so there's my question. I'm looking for what the size of the gear for a bike with a 26-inch wheel. Well, what are you told in the question? You're told the gear size for a 22-inch wheel. You want to know the gear size for a 26-inch wheel. All right, now, real fast. This question can be solved using a proportion. You're not only allowed to use proportions when you're solving a conversion question. Proportion can be used to solve almost anything in math. So with that being said, what is similar about this that is similar? What is the same about this that's the same about those conversion questions that you've seen me work? Whether it was on the videos that you've watched from my website, or if it was yesterday, or if it was from the conversation we had yesterday in class about proportions. What's the same about this is a simple thing. You're told 3 things and you're looking for one thing. What was the size of the gear for a bike with a 26-inch wheel? All right, you want to know the size of the gear. Not for the 22-inch wheel, but for a brand new wheel. Okay? So what you have here is a situation where you got 3 knowns and 1 unknown. So you take the gear size and put it over the wheel size. Now, does it matter how you set that up? No, makes no difference whatsoever. So you take that situation and you create a proportion based on how we decided to do this. And like I said, it doesn't make any difference. You can put this one up here or that one down there. It makes no difference. That was a personal decision that I made. You could have done it differently. The gear size for what the information you're given, 4-inch gear. So 4, 22-inch wheel. What's got to be true for the other side? Yes, it's got to be mirrored. On the other side, it's got to be the same. So do you know the gear size? You don't have any other gear sizes in this question, correct? No other gear sizes. So that's an unknown. All right, what other thing do you know? You want to know the gear size for a 26-inch wheel. So that 26 goes down here. See, look, 3 knowns, 1 unknown. So now all I have to do is what? Cross products, okay? 26 times 4 and 22 times x. What's true for these? They're equal to one another. So 26 times 4 is 104, and that's equal to 22 times x. If you've watched the video, you know how this works. If I want to get x by itself, because that's what I want to know, that's my unknown, I want to solve for it. If I want to get x by itself, if I want to get it all alone, then I want to do the opposite of what's happening here. What's happening here? Multiplication. The opposite of multiplication is division. 22 divided by 22 is, of course, 1. So basically that goes away and you're left with just x. But you can't just do that to one side of the equation. You got to do the other side too. So you got to take this and divide it by 22. All right, when you set all that up, you end up with an answer of 4.72 with a repeater bar. Okay? The 104 on the inside, the 22 on the outside. That's the answer that you would end up with. Okay? So take this into consideration. You don't only have to have a conversion question, or you don't only have to be messing with conversion for a proportion to work. All right, so let's erase this real fast. And let's go on to the next question I have for you. All right. Now, yesterday, during tea period, I was gracious enough to allow you to come into my room or let Miss Lloyd or Mr. Magoo show the video to you from the website. So you've seen some of this percent increase, percent decrease. Most of it you have not seen. Okay? You've just seen a tidbit of it. You've seen Professor Berger work a question. And if we're honest with one another, you probably didn't catch most of what he said in that video. You were just writing information down, which is fine. That's okay. I wanted you to see him work a problem. That's really all I wanted you to do, and to write some notes down in your composition book. By the way, you should be writing down what I'm writing. That should be clear. All right? Now, Amber got a raise and her hourly wage increased from $8 to $9.50. What is the percent increase? I'm looking for the percent increase. Now, if I want to find the percent change, if I want to find how something's being changed and represent it as a percentage, then what I have to do is solve this division problem. I have to take this division problem, the amount changed, or the amount, tell you what, a better way of writing that would be the amount of change, okay, over the original amount. If I solve that division problem, then I can find the percent change of anything. I just need to know those two numbers, the amount of change that happens and the original amount. Okay? So in your composition book, you should already have this written down under the definition percent change. We wrote that down yesterday in class. That was one of the vocabulary terms. So you already have this. Amount of change, original amount. But remember, you're writing down everything I write. Good job. All right. What is the original amount? All right, well, Amber got a raise, and it increased from $8 to $9.50. So which one of these is the original? The 8 or the $9.50? Correct. The original amount is the $8. Now, how do we determine the amount of change? That's pretty simple if you just slow down and think about it. The amount of change is how much something is changing. So if you wanted to think about this a different way, you can think of it as how much something changes. Now that's a what problem? Subtraction. 950 minus 8. That's easy. It's $1.50. Division problem. Which one goes inside? Top number. 8 on the outside. 8 doesn't fit into 0. Excuse me, 8 doesn't fit into 1. And every time something doesn't fit, I put a 0. Bring my decimal up. 8 fits into 15. Twice. No. Too big. It's in there once. 15 minus 8 is, of course, what? 6, 7. Drop the 0. 8 goes into 70. 8 times 64. Give you a second to catch up if you're not keeping up with me. Alright, that's good enough. Subtract that, you get an answer of 6. Because I have to, I got to do the little borrow thing there. That turns into a 6, that turns into a 10. 10 minus 4 is 6. Alright, got to continue going. 0. 8 goes into 60 7 times. Alright, now we've been following this rule of stopping on the third number. Now, I want to say something right here. This situation, even though you're dealing with money, I'm not thinking of that as money. It is money, don't get me wrong, but I'm not thinking of this division problem as a money division problem. I'm thinking about this number right here as what I've already called it. It's the amount of change. And that's not always a money amount. Okay? We'll do another question here in a second that this is not a money amount. So we can't think of this like that, as just money here. Now I say all that to say this to you. We're still going to keep stopping on the third number. Because generally what happens on these type of questions, what are you solving for? Are you looking for a decimal answer? What is the percent increase? You want a percentage. Now what they'll do to you on your test, and most of the worksheets that I'll give you, the percentage is rounded. And sometimes there's not even a decimal included. You just round it to the whole number and you go with that percentage. So we're going to stop on the third number because that's what we've been doing. That's really the only reason I'm stopping on the third number. So I'm not even going to mess with the subtraction step. I know that 8 times 7 is 56. So I know that's why that 7 belongs there, because it's lower than 60. All right. So the decimal that I end up with, $1.50 divided by 8 is equal to 0.817. All right. And of course that we don't know the rest of that, so I'm just putting those dots there because we didn't finish the problem. But this is not a percent, is it? So I got to make this into a percent. Well, how do I make a decimal into a percent? A decimal into a percent. 2 hops right. 2 hops right. So I take my decimal point and I go 1, 2 hops right. Very simple. So 18.7%. And like I said, most of the time, this question would be answered by saying 19%. Okay? Most of the time. Well, that's not all the time. That's why we're just stopping on the third one. All right? So, make sure you've got that written down. Remember, we were looking for a percentage the whole time, so this decimal wouldn't work. We had to make it into a percentage as our last step. All right, so let's move on to the next question. This board is acting weird again. All right. Question number 3. Question number 3. Let's read this. David moved from a house that is 89 miles away from his workplace to a house that is 51 miles from his workplace. Determine the percentage that would show the change in distance from his home to his workplace. Determine the what? Percentage. Still looking for a percent change, aren't we? Determine the percentage that would show the change. The percent change is found by determining the amount of change divided by the original amount. We're going to call it OA. All right, so the amount of change over the original amount. Well, how do we find the original amount? We've got to determine where he was to begin with. Was he 89 miles away from the workplace to begin with, or was he 51 miles from the workplace? David moved from a house. So if he moved from this house, then this is the what? That's the OA, isn't it? So 89 is the number on the bottom. How do I find the amount change? I subtract the two numbers. 89 is the original amount, so I'm subtracting the 89 and the 51. Real quick, is this an example of an increase or a decrease? Well, we'll come back to that here in a second. 89 minus 51 is, of course, 38. Gets me 38 over 89. I'm not going to do that division problem for you. I'm not going to make you sit through that. You end up getting an answer of 0.426. And, of course, we stopped on the third one again, so that's why I put those dots there. All right? So what is this percentage? Well, how do I make it a percentage? What did we say just a second ago? 2 hops to the right. So 1, 2. Ends up being 42.6%. Then of course, the answer that would probably be on a paper that you did would be what? What would that 6 be telling that 2 to turn into? Correct. It'd be telling it to bump up to a 43. Like I said, either one of those answers could show up. Most of the time, it's that one. All right, so was that an increase or a decrease? Because if you remember from question number 2, it asked for a percent increase. So it was obvious what it was. It said it in the question. This does not say. All it says is determine the percentage that would show the change in the distance from his home to his workplace. So is this an increase or is it a decrease? Let's think about it. If you're working, if you live in a home that is 89 miles from home, if I'm here, all right, if I'm right here and I'm 89 miles from home, okay, or from the workplace, excuse me, and then I move to a home that is 51 miles from my workplace, if I was here and now I'm here, which one is closer to the workplace? That's correct. This guy. So is that an increase or a decrease? That's a decrease in distance, isn't it? He was 89 miles. Now he's 51 miles. So that's a decrease in distance. So one of the ways that they can show that on a test is by making this a negative number. Okay? And that can actually show up on a griddable now, because you know griddables have the positive or negative option. Or it could be one of the answer choices. So you need to keep that in the back of your mind when you're dealing with a percent increase or a percent decrease. You need to remember that sometimes they can describe it with the positive or negative symbol. Okay? That's how you would say, okay, this is an increase because it's positive whatever. Or if this is a decrease, which this one is, I would say it's a negative 42.6% or a negative 43%. Okay? All right, let's move on to the next. All right, question number 4. Guess what? It's the last one. Yay! Last set of notes. Okay? Make sure you're writing down what I'm writing down. The grizzly bear population in Yellowstone National Park in 1970 was about 270. Over the next 35 years, there it is, increased. So what would that be represented by? Would that be represented by a positive symbol or a negative symbol? Yes, positive symbol. Duh. Increase is positive. Negative is decrease. Okay? So increased by 115%. What was the population in 2005? All right, so recognize first of all that they didn't ask you for a percentage, did they? Okay, so when they ask you to find how something was changed by a percentage, now let me show you what I'm talking about here. The population is what this is all about. 270 in 1970. Okay? Then it increased by about 115%. How did it increase? By that percentage. Right? It increased by 115%. So if you want to show how something is changing by a percentage, or if you want to find how something has changed by a percentage, then what you first have to determine, is it an increase or is it a decrease? Now we're told in this question, it's an increase. So I'm going to put myself a little up arrow here, representing that I know that this is an increase. Okay? Oh, that arrow right there tells me that it's an increase. What would I put if it was a decrease? Yes, a down arrow. Okay, so once I've determined that, I'm going to kind of keep that in the back of my mind while I'm trying to figure out how or what the value of that change is. Because I still need to figure out what the population is in 2005 after I've done this increase of 115%. All right, so if I want to figure out how to find how something is changed by a percentage. Give you a second. Then I multiply the percent, okay, that's going to be the one that's given to me, by the number being affected. Now what this last part means, by the number being affected, is basically the 115%, what is it affecting? The bear population. Now what number do you know represents the bear population? The only one you know is the 270, right? So when I'm talking about the number being affected, it's also got to be given to you. Now I'll be honest with you, sometimes it'll be directly given to you, and sometimes you'll have to do a little something to the question to find out that number being affected. Maybe a subtraction, addition, possibly a multiplication, maybe even a division. But every once in a while it can be given to you like it is here. But sometimes you'll have to mess with it to figure out what that number is. Anyway, if I want to find out how something is being changed by a percentage, all I got to do, multiply the percent by the number being affected. Okay? So not really difficult. Make sure you've got that. Okay, so $115 times 270. Can I multiply percent? No. Can't multiply percents, can't divide percents, can't add percents, can't subtract percents. Okay, especially when we're dealing with a whole number that's next to it. What do I have to change this into in order to be able to multiply it in this situation? Correct. A decimal. So how in the world did I go from 115% to 1.15? Well, if I make a percent into a decimal, all right, if I want to make a percent into a decimal, then I hop 2 times to the left. Okay, so percent into decimal, 2 hops left. 1, 2. Bam. There's my percentage. Okay, so I won't make you sit through the multiplication process of that right there. You end up getting 310.50. Okay? 2 numbers in the answer, excuse me, 2 numbers in the question, 2 numbers in the answer. Alright? So is that my final answer? It isn't. It's not. Okay, because there's a second piece of this. You remember me talking about keeping this in the back of your mind? What does that represent? An increase. An increase of what amount? That amount. So if this is an increase of that amount, what do I need to do with this? I need to add it to my original amount, and then that would tell me what the population was in 2005, because it's an increase. Okay? I've got to take this and add it to my original amount because of the fact that it's an increase. So when you add those two, I mean, you end up with 580.50. So there's your population in 2005, because it had a 115% increase, which was equal to 310.50. 580 and a half bears showed up. How do you think that would show up on a test? Can you have half of a bear? No. So would you represent that by going down to the 580? By like just cutting off the 0.50? All right, would you say I had 580 more bears? All right, or excuse me, would you say I had 310 more bears? They gave me a total of 580 bears? No. You take that thing up and go to 581, because that would better describe the situation, because you can't have half of a bear, right? Okay. One last thing I need you to write down, and then you can start doing a little bit of work. If it's an increase, then I add the answer to the original amount. Alright? That's exactly what we just did. Yes, we took the 310.50 and added it to the 270 because it was an increase. Well, if it's a decrease, why did I put if it's and? I'm sorry about that. Anyway, if it's a decrease, then I add the, you think I do the same thing? No. What's decrease mean? Yeah. Subtract the answer from the original amount, or the OA. Okay? Give you a second to make sure you've got that written down.